Okay, so we're going to go ahead and start the review for exam 2 for Java. This is exam 2 fall 2014. So we're going to go ahead and go through the whole exam. First question is asking, with the data input stream class, what can we do? So whenever we're looking at this, there's some code on the right side. So if you notice, this code isn't really relevant to this question. We're not gonna look at this code until we get to question 5. So to begin with, let's see what it's asking. Data input stream class, which of the following is true? The read method can only read one character at a time, so we're not reading one character, we're reading what's in the first position of the data input stream class. So for number 1, this is a kind of a knowledge question. The answer is D. But the read method can only read one field at a time. So if we're talking about fields, if you've done the old master, new master, like with the pennies that Professor Knighton goes over, you note that you have a transaction key that kind of looks something like A1, N1, K1, C1. So each of these things is one field. So basically what it's saying is that it can only read this one at a time. If we call this a field, we can only read one of these at a time with data input stream. That's a knowledge question. It's just like a kind of like a definition that's written in one of the PowerPoints. So number 1 answer is D. And then number 2, which of the following is true? So you open a file by creating the appropriate object, and you close a file by deleting the appropriate object. So for 2, the answer is A. You open a file by creating the appropriate object. So whenever we open a file, we store that in an object, and we use that whenever we say, for example, like new file, something like that. We're making an object and we're storing it. But when we have to close the file, we don't necessarily have to delete the object because it's possible that we might need to use it later on in the program. So for number 2, the answer is A. Once again, these are knowledge questions, so it's kind of just reading the book or the PowerPoint just to kind of know what the answers are. For this, I recommend writing it down in your cheat. There's some cheat sheets that I've posted on the Discord. You can see them on the left side. There's a channel that's called Java Documents, and it has everything. So number 3, an object of the file class is required for what? So it's required in order to read data from or to write data to files. So it's not required to write the data. So it's not A. And B, in order to get information about files. So when it says to get information, it's talking about the various things that you get from the file class. So one of the PowerPoints has some methods, for example, like get length or get name, something like that. So these methods are used with the file class. And what it's saying about getting information, it's basically saying like if you want to know what kind of file it is, or if you want to know something else. So for instance, right here we have the file, we know that it's in .pdf, and that's if we said something like get name, we would return coupling decision matrix. And if we wanted to know the size of it, we would know it's like 120 kilobytes. So that's what it means by getting information files. So moving on to question number 4, with the following code, what happened? So we want to see what this code is doing first of all. So it's saying file position was employee ID 100, employee file .c, file position, record size. So we're basically trying to see what this code is doing. So whenever we look at this percentage, it's basically telling us what the maximum is. So in this case, it's telling us that the maximum is 100 from right here. So when we do employee file.seek, file position, record size, we just basically want to know the minimum of access records is 100. Notice that it's not the size, it's the number of records. And this is once again just one of the knowledge questions. So moving on to question 5. How many records will be written to the new master file? So now we want to go ahead and look at this program. So whenever you look at any of these programs, the first thing you want to do is figure out where the main is. Just make sure that you're actually running where you're supposed to be running. So when we look at this program, we notice it's a class payroll, and then we have some data input stream, transaction file, old master file. We have some attributes up here, and our main starts right here. So because our main starts right here, everything underneath we won't run any of this until we call it in the main. Want to note that we're going to start the program right here. So we want to make sure we know that before we even look at it. So now it's asking us how many records will be written to the new master file. So when it asks how many records, so if you notice, we're writing two files, right? But we don't know what the file is. For example, the file could look something like this. It could look something like that. But we don't know what it actually looks like. However, this question is set up so that you can answer it even if you don't. So we want to go ahead and make up some data to help us kind of visualize what it's like. So let's say that this is like the old master, and then this is our transaction file or something like that, or our transaction file. Yeah, we can say that. So when we look at new master file, we want to see. So we're saying we're writing something to new master file, right? So we're going to be looking for something that says like write. Something that says write, and it's going to be for new master. So we want to figure out where that happens. So if we look at this, we're going to be in the main first, and we see we're first creating the files. So we created one file called transaction file, and we make data input stream. Follow that, we made another one called old master file, and we have a new one. We have three files we set up. Then we're reading the transaction master. So in this case, for example, old master is A1 and transaction is 1. And then we're saying as long as the transaction key is not at the end of the file. So as long as we're still here and we're not like trying to go past A1, then this will run. And then we can see that write new master appears right here. So when we run write new master, we're going to go all the way down here to write new master. And then we're going to see new master file, you write this, you write this, and you write this. However, if you notice, the only way that we run write new master is if transaction key compared to old master key is greater than 0. And as long as we're not at the end of the file for both. So transaction key can't be at the end of the file, and old master key can't be at the end of the file. So we have to still have some sort of transaction key. However, if you notice, read transaction and read old master happen at the same time. So when we first read them, we start at A1 and J1, and then let's say we run this whole program and it runs again, then we'll be at N1 L1, and then get O1 P1, and then J1 A1. So if you notice, every time old master runs, transaction key runs as well. So for 5, we actually would know that it's the same amount. So it says how many records are going to be written to a new master file. So a new file, every time there's a new file, every time we read these, we write it to the new one. So it's going to be the same amount as an old master file, because it only writes to the new one every time the old master is read. So for 5, it's B. So the answer is not like a number, it's not like 5 records are written, it's just that conceptually it's the same number of records. Okay, so how many fields are there in each transaction file record? So in transaction file, we basically want to go look where transaction file is. So transaction file is, so we have to look for it over here. Transaction. Okay, so we have trans key. Oh, I'm sorry, it's right here. Transaction file, and transaction file. So what this is doing, it's saying, okay, it's asking how many records are there in each transaction file record. So we have the record here. So let's say this is our transaction file. It contains some records, right? So let's say that it contains like address, and state, or yeah, or like state. So if that's the case, every time we read the transaction key, we transaction file read def, we read the address as a string, then we read the zip code as a float, the deduction. So it's reading the first one as the first one, the second one is, So we can see that there's 3 different times that it ran. So for how many fields there are in each record, that's 3 fields. 3 fields. 3 fields because we have 3 times. So the next one is what would happen if you replaced pay rate old master file read float with year to date gross pay? Okay, so I'm gonna go back to this previous example. So I'm gonna kind of make it a little easier so that we can see what's going on. So let's say that this is our file, right? So this is our file. File contains like a lot of addresses, right? So let's say that this is the order, and then let's say that realistically it'd be like 123 street. Also have, let's say that we also have like a zip code. Let's say it's like 3. 8 is like letters, so like Texas, TX, right? And then we also have like 453 drive, have the zip code 45R, have like MN for like Minnesota, have avenue, and then we have the zip code 843, and Arizona, for instance. So let's say this was our file and this is the information contained. So if we have something, and we note that when we read the information, it gets read in order, right? So let's say that we have like a program that like says like read or what is this one? Read UTF, right? So it says like UTF and read float, and then we have state read UTF. So let's say that zip code is a float, just for whatever reason that makes sense. So if these things are going to run in order, right? So when read UTF is run, it's going to save 123 street. That's what it's going to be. And then when read float runs, then we read 123.1. Then when we read UTF again, then we run state. And then this is for the first set of the first record. And then we run it again, and then we would be doing it for 543 drive. So read UTF would store 543, read float would store 454.2, and read UTF would store MN, so on. So if we notice, it's kind of tied. So the UTF is kind of tied to the 123, the float is tied to this one, and then Texas is tied to this one. So notice what happens if we do this. So let's say that we swap these, right? So we get rid of this, and we put it right here. So UTF, it's going to be for strings. So originally we were storing a string where a string went, and then a float where the float went, and then a string where the string went. But we just swapped the order. So because we swapped the order, now we're trying to, when we run this one, we're reading a string, and we are storing in a string. So this runs fine. But then when we run this float right here, we try to store that as a string, and then it gives us an error. Because it has to be a float. So we get an error right there. So if we notice, it has to be in the right order for this program to work. So we can't have it like that. It has to be in the right order. So that being the case, we can kind of look at what this is doing. So number 7 saying, okay, what happens if you replace this stuff? So basically what it's saying, you have to think about it kind of like what I said. If you replaced like read float with read UTF, what would happen? Well, for us, it would give us an error because it's the wrong file. Or if it wasn't, it would just be logically incorrect. So let's look at 7. What would happen if you replaced pay rate equals old master file read float, and you swap them? So you're basically swapping the positions. So okay, so we said that if they're a different type, it'll give us an error. But what about, let's say that we don't even have a zip code. So let's say there's no zip code. It's just a state and an avenue, right? So if we say like read UTF and read UTF twice, then the first time it runs, it's storing, let's say you have like an integer, right? Like integer address equals this, and you have integer state equals, right? So when we run read UTF, you're storing the street as the address, so that's correct. And then when you run read UTF again, you're storing the Texas in the state. But what if we swap the order of these? So if we swap the order, then now what we're doing is we're saying that the state is equal to the street, because remember, this runs it in order. So when you see read UTF, it first runs this thing. Now it's saying that the street is a state, and then when we run read UTF again, it's saying that Texas is the address. So this doesn't give us any errors. There's no errors. However, we're saying that the street is the address and that the state is the street, and that doesn't make sense. It's giving us a logical error. Like, it'll still run correctly, but the calculations are wrong. So for 7, if we swap the spot, so we're basically saying the pay rate, it goes first, and then the gross pay goes next. But if we swap it, then now we're saying that the pay goes where the we're saying that the pay rate is going with the gross pay, and then gross pay is going with the pay rate. So for 7, the program is still going to run, but the calculations are wrong, and it's similar to what I just did here. We're kind of swapping the order, so it's still running, but now it has it mixed up. Okay, so number 8. If you opened up old master file in TextPad, which fields would you be able to read? So this one is a knowledge question as well. For this one, it's C, old master key and address. The reason for this is that you can only read strings when you open something with TextPad, and old master key and address are the only ones that are strings. So old master key is right there, it's a string, and then address is also a string. Everything else that's listed here, like pay rate and gross pay, these are floats. You could understand strings, and then all fields is wrong. So old master and address are the only, because they're the ones that are strings. Okay, so number 9. What would happen if you deleted address equals old master file dot read UTF? So this is kind of what I just did earlier. So whenever I told you, if we did have the zip code with like the float, right? So the zip code, and then you have 12.1 and like 0.1, 6.1. So we have like int zip float. So and then okay, so if we run this, there's no problem, because the first one is a string and it's being stored as a UTF, which is a string. The next one is a float, it's being stored as a float, and then TX is a string and it's being stored as a string. If you delete the zip though, so if you get rid of this line, then now what happens is we run this line, the address gets saved correctly, but then now we try to save this float as a UTF, and that gives you an error. So which is why for number 9, if we deleted this, we would get an error, and the program would stop when we get an error. So if you want to look exactly where it's happening, we're looking for pay rate equals old master file dot read float. So we're looking at this right here. So basically, the first time it runs, it's reading UTF. So we assume that there's a string there. Then there's an address, right? So we're saying that's a string. Then there's a float. So if we get rid of this line right here, then the second one is supposed to be a string, but pay rate is going to be a float. So then we get an error right here, because pay rate is a float. It's actually a double pay rate, and we're trying to put a string into it. So for 9, it would give us an error because we're trying to put the wrong data type in that variable. Okay, so number 10, we're looking at a different piece of code. So this is a basic string manipulation. So go ahead and look at that. Okay, so code in line 1, what? So the first one is this one. So line 1 is not this. Line 1 is given by the numbers. So string dog equals new string red. So this is just a shorthand method of writing string dog. That's simply what's happening. So if this looks familiar, it's because normally when you write a class, so let's say you write like like student first student equals new student. You usually do this when you make a class, right? So it's kind of the same thing, because in Java the string class, or I guess string is a class, as opposed to a primitive. So it's actually the same thing. However, in Java you can make a shorthand and just call a string and then whatever the name. So these are the exact same thing, and there's no difference at all. So for 10, the answer is A. It's the same line as string dog is equal to red. So then what else is there? The code in line 7 results in what? So okay, system.println bird character at string number dot length. So for this one, it's important that you know how how the numbering works and when to start counting from like 0 and when to start counting from 1. So this is, we should write this down. Okay, so if we ask you for the length of something, so if we say length, then we're talking about how long is the string. Okay, so if we say length, we want to know how long the string is. So if we say, for example, string dog is equal to, and then we say like, I don't know, woof, the length of dog. So if we did like dog.length, the length for this is 4. Why is it 4? Because there's 4 letters. W-O-O-F. The length is 4. But if I said, okay, at what index, so at what position is the F? The F is at position 3. It's not at position 4 because you count it like this. Woof. This is position 0. This is position 1. This is position 2. This is position 3. So the length of the string is 4. However, the positions start from 0. So if I asked you like how many numbers are there right here, there's 4 numbers, right? 0, 1, 2, and 3. It just so happens that we started counting from 0 instead of counting from 1. So this, the length of this, length is 4, just like 1, 2, 3, 4 is also 4 numbers. So if we ask you length, then we're saying, okay, literally how many letters is the string. But then if you see like index of, then you have to remember that you have to start from 0. So if we say, what is the index, what is a dog index of 3, then that would be 0, 1, 3, it'd be F. Or what is the index of F in dog? It's 3. What is the index of W? It's 0. So you need to know this basic concept to be able to do this question. Okay, so let's go ahead and look at it now. So 7 is kind of a complicated one. So you don't start reading it from the outside. You start reading it from the very inner parentheses, right? So system.println, bird character at, and then you go string number dot length. So the first thing we're running is this, string number dot length. So go over to string number, and what is the length of it? So the length of this is not 5. The length of this is 6. Why is it 6? Because it's 0, 1, 2, 3, 4, 5. That's 6 numbers, right? That's 6 numbers. The length there is 6. Okay, so this whole thing basically just replaces whole string number dot length. That just means 6. So you can kind of rewrite this statement. It's kind of rewritten to bird character at 6. Instead of saying string number dot length, string number dot length is 6. So you can just put a 6 there. So now if we see bird character at 6. Okay, so we are talking about bird, which is the string right here. We're going to put the string, and we're going to put the numbers, so 0, 1, 2, 3, 4, 5, 6. So what character is there at position 6? The character at position 6 is this D, right? So if we say, okay, bird character at D, so now we're saying system.println, and we're just going to say, so for 11, the answer is C, even though the letter is D. So don't get confused, because sometimes you think, okay, the output is, and then you select the answer D. But no, the answer is C, letter is D. Okay, so that was number 7. Okay, so line 8. What happens with this line? Okay, so once again, read it from the inside. So mouse dot index of letter. Okay, what is a letter equal to? Letter is a character, and it's just A, right? So we want to say the index of A. So that was for line 8. So we want to see basically where does the letter A happen in mouse. So get this right here. So we have black gray. So the position is 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6, 7, 8. We have 8 positions, and we want to know where A happens, right? So we're saying index of A, pretty much. That's what we're saying, because letter is. So when we say index of A, you don't go to the first one. You actually have to go all the way to. So okay, I'm sorry. When we say the index of A, we're only looking at this first one. So even though we see 2 A's here, right? There's one at position 2 and there's one at position 7. These are both answers. So the possible answers are A, it's D, and E, right? So the way the Java compiler works, if you say index of like a letter, it only returns the first time that this happens. So if we do index of A, for us, the output is going to be 2. So for 12, it's D, and it's just something that the way the Java works. So if you say index of A, even if you have like a million A's right here, it's only going to print out whatever the first one is. So for this instance, it's D because it's 2. So then 13. The code in lines 9 through 15 returns in what? So we're looking at this right here. So let's put this. If bird.substring 0 to 3 is equal to blue. Okay, so we're going to look at bird, and then we're going to look at substring 0 to 3, and then we're going to see if that's true. So bird, it starts with BLU, right? So whenever we see 0 to 3, you don't include this 3. So you're only going to be looking at positions 0 through 2. So once again, if it's saying substring from 0 to 3, you don't include the 3. 3 is telling you where to stop, but you don't include it. So we want to look at bird. Bird is, and now we want to look at the positions at 0, 1, 2, 3, 5, 6, 7, 8, 9. So BLU is 0, 1, 2. So 0 to 3 is blue at all. It is blue. So if we said, for example, we said this right here, the output of 0 to 2 is actually just BL. As like I said, you don't include 2. So if it said 0 to 2, it would just be BL. In this case, it does have the 3. 0, 1, 2. So it is blue, so this can be correct. I'm going to go ahead and go to. Then what do we else we have? So if bird searching is for blue, then we're going to go to the next if statement. So then we have this if statement. Let's type to this one. Oh, okay, so there's actually one tricky question about this. So when we look at this right here, blue, red, green, yellow, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So BLU is 0 through 3, right? However, there's one tricky thing that Cooper has done with this question. So you see how there's 2 equal signs? If you're dealing with strings, you can't use an equals, remember? So if you have like 2 strings, you have to use dot equals like that. So even though from 0 to 3 it is BLU, because there's 2 equal signs and it's comparing strings, this is actually false. So this if statement is false, so that means this if statement never runs, which means that this else, because these two things are tied, and these two are conditional upon this being true. So because this first one is false, then we go straight to the else, and the output for this is just actually maybe. So for 13, the answer is B. And then 14, it's similar. So 14, we're looking at comparing strings again. So we're going to be looking from line 16 to 22 right here. Okay, so from substring 0 to 3, is that true? So we already saw once again that these double equals means that it's false. So this if statement is not true, which means that we're going to run this else. Okay, and this else statement is saying that we're going to run this if. Okay, so it's saying if black gray equals ignore case mouse. So mouse is equal to black gray, and this is also equal to black gray. So normally these are in the same. However, because it's saying ignore case, then it's actually true. This if statement is true, so we print no. So for 14, the answer is. So now 15, the code in line 23 results in what display? So system on primary line bird substring 2 to 3 plus mouse. Okay, so let's look at this and then write what bird looks. Okay, so bird is equal to this. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So we're looking at bird substring 2 to 3, right? So 0, 1, 2. So we're starting at this U and we're ending at this 3, but we're not including it. So this is just equal to 2. Sorry, it's just equal to U. So this is 2, and then we're adding on mouse dot substring at 4. So we're gonna write mouse. Figure out where position 4 is happening. So that's 2, 3, 4, 5, 6. So at 4, this is K. So have U K. That's the right one. 15. We have the UK. Mouse substring plus 4. Okay, so we're adding the K, and if we notice, there's also not a comma here. So if we say K, if we want to only print one letter, notice that, for example, right here, we had it only printed one letter, but we had to tell it, okay, you're gonna start here at this position 2, which is the U. Start here, and you're gonna stop right here, but don't include this E. So just only take the U. But here we're not telling where to stop. Here we're telling it, okay, you're gonna start right here, but we didn't say 4, 5. We just said 4. So because we just said 4, we're actually gonna include all of this. So we do have the K, which is substring 4, and we also have to include 4 letters. So the final output ends up being UK gray. We're gonna look for this answer in the answer choices, and looks like we have it right here. 15, it's B. It's gonna be UK gray. Okay, 16. The code in line 24 results in what display? So right here. Zone that out and print line bird character at number. So we want to see what number is at. So number is equal to 4. So we want to see bird character at 4. So we want to see 0, 1, 2, 3, 4, which is, looks like it's the R. And 16, yeah, it's the. So once again, we want to just look for position 4. I have it right here. So 0, 1, 2, 3, 4. R is a position 4. So if you get confused with this stuff, one easy tip is to just go ahead and write the number to the position here. But remember, if he asks you for the length, so for black gray, the Y is a position 8 and the B is position 0, but the length of black gray is equal. The length is 9. Okay, so that was it for up to question 16. So keep going. So what is this? Okay, so these are all, once again, knowledge questions. So which of the following is true? So for this one, the answer is methods are overloaded when their first names are the same, but parameters are different. So basically just saying, do you know what overloading means? So make sure you know the definition of overloading. If you don't know it, you could just write this question down on your cheat sheet and then that'll help you get it right. Then 18, which of the following sentences regarding static methods is true? So for 18, it's B, the programmer does not need to create an object in order to use a static method. So if we notice, like, main is always static, we don't have to make an object of main to be able to use it. That's one of the ones right on this one. 19, which of the following is true? So 19, it's A, when you pass a variable declared as an object, you're passing by reference because you're not really calling the class, you're calling the object of whatever type of class it is. Number 20, it's which of the following is true regarding variables declared within one method? So 20, the answer is D. You can have two variables with the same name as long as they're in different and separate blocks. This one is going to be relevant in this. So if we see, we can have variables that have the same name, right? So we have like, okay, so you see like country name right here, and country name is right here as well, and it up here. So you see that we have this program is like, which is one program. There's a lot of things called country name, but it's okay because they're all within their own. That's what it's asking. 21, it's D. Then 22. If a variable is not declared before it is used, what will Java do? So if you don't declare something before you use it, it's just going to give you an error. So what that's saying is if you say something like system.out.println say dog, or saying string dog equals woof. So if you try to do this, you're going to get an error because you're trying to print out dog before it exists. Sure. So 23, execution of the following code will result in what? So we start our loop count at 0. As long as it's less than 9, what happens? So for 23, the answer is actually it's C. So the reason we kind of look at how we run loop count starting at 0, right? 1, 2, 4, 5, 7, 8. And you would think that, okay, as long as 8 is less than 9, then that's. However, because the plus is on the left side, you still run it whenever we compare. So even whenever we get when this false, we're still going to add one more to the loop. So even though it won't run, the loop count itself changes. So we start from 0, 1, 2, 9. So when it's less than 9, and then we have to actually add one more. So when we get to this one, we end up at loop 10. And that's because of the way that this plus is positioned. So once again, normally you start at 0, you go all the way to 8. 8 is the last time that this, right? When 8 less than 9. Then you add one more, and then you get 9 is not less than 9, right? So normally you stop there. Because there's a plus, then you have to add one more. Go all the way to the regular 9, then you have to add one more. Okay, 24. Which of the following sentences is true? So 24 is B. Double can hold a larger number long. So there should be a chart somewhere on one of the cheat sheets that just tells you like which sizes primitives are bigger than the other ones. Okay, so 25. 25 is which of the following sentences is true? 25. The order in which methods are defined in a class does not affect the order in which they are executed. So you can put methods however you want. The only way that, so what is it saying? It's like, okay, let's say you have a main method, right? Like that, whatever. Then in here you have like public calc grade or something, and then you have public, and you know, public return name. So it doesn't matter if you put return name after calc grade or whatever. What matters is the order in which you call them. So if you call calc grade first, then it'll call it. If you call return name first, return name, and then calc grade, return name will get called. So that's what that. So 26, method code in which class is used to read input from the keyboard. So 26, it's A. So if you say anything about reading from input, it's always a button, as it doesn't use it until you press enter. This, so we have this, right? I can type in a bunch of stuff. It doesn't matter what I type in. This is buffered. It's not until I press enter that, if I press enter now, 1, 2, 3, enter, then it tries to run. That's what a buffered input. 27, a method code in which class you set to what. This one is D, print stream. Print stream is when we use the display to the computer. One easy one that we always use is system.out.print line. So the print right here. So I'm gonna go ahead and stop the video here because I'm not sure if my microphone has been working this whole time because I've been having trouble with it. So I'm gonna stop the video, make sure that my audio is working correctly, and then I'm gonna zoom it. So if you're watching live, it should be back up in like 5 or 10 minutes. And if you're just watching the video, then just look for the next video in the playlist.